Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 21 and 22, which account for 13 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 21. So we have the function g of x equals 2x squared, h of x equals x add 1 all over 4. Part A, show algebraically that the x-coordinates of the point of intersection of the curve with the equation y equals g of x and the line with the equation y equals the inverse function of h of x are solutions to this equation. Okay, so first things first, y equals g of x is simply this function here. However, y equals the inverse function of h of x. So let's find that first. So I'm going to rearrange this. So I'm going to write it as y equals x plus 1 over 4. And then I'm going to rearrange it so that y is the subject. So the first thing I'm going to do is multiply both sides by 4. So that becomes 4y equals x plus 1. That's eliminated that fraction. Now I'm going to subtract 1 from both sides. So 4y subtract 1 is equal to x. Now I'm going to rewrite this with my inverse function notation. So x becomes my inverse function notation and y becomes x. So that's the first starting point. So now we're showing algebraically that the coordinates of the points of intersection of y equals g of x and y equals the inverse function of h of x are solutions to this equation. So points of intersection means we need to make these two equations for y equal to each other. So g of x equals 2x squared, which is equal to the inverse function of h of x, which is 4x subtract 1. Now I'm going to show that they have solutions to this equation, so I'm going to rearrange this to make it equal to 0. So I'm going to subtract 4x, so 2x squared subtract 4x equals negative 1. Remember, you're doing that from both sides. I'm now going to add 1, so 2x squared subtract 4x plus 1, and then when I add 1 here, that becomes 0. So now what we've shown is that this equation matches this equation, therefore they have the same solutions. Okay, part B, use an algebraic method to find the x-coordinates of the points of intersection of the curve y equals g of x and the line y equals the inverse function of h of x. Give your answers to 2 decimal places. You must show all your working. So remember, we just said that the points of intersection have solutions to this equation. So this is the equation that we're going to start off with, this quadratic equation here from part A. Now it tells us that we need to give our answers correct to 2 decimal places. So I need to solve this quadratic equation, but the fact that I need my answer in 2 decimal places tells me that I can't factorise it. I'm not going to get integer values that would go inside brackets to make my life easy. So I either need to complete the square or use the quadratic formula. I'm going to use the quadratic formula. So x equals minus b plus or minus b squared minus 4ac square rooted, but that is all over 2a. So my a equals 2, my b equals minus 4, and my c equals 1. So minus b, so I change the sign of b. So x equals 4 plus or minus b squared minus 4 times a times c, all square rooted. So all I'm doing is substituting in my values for a, b and c. And this is all over 2a. So I'm going to stick that in my calculator now, guys, exactly as you can see it there. So I've got 4. I'm just going to put plus because I can't put plus and minus and get something nice to work with. So I'm going to put my square root. So I have got -4 squared. The brackets are important here, guys, just to make sure my calculator doesn't do anything stupid. So I've put everything in and I've pressed equals. So x equals 1.70710671. But I also need to put it in as a minus. So I'm going to go up, and instead of the plus here, instead of this plus, I'm going to change that to a minus. So x also equals 0.29289321888. So it wants my solutions to 2 decimal places. So I'm interested in 2 decimal places. So this 7 is going to change that to a 1. So that's 1.71. That 2 isn't going to change that 9. So that's 0.29. So they are my solutions to 2 decimal places. Question 22. The diagram shows the velocity v meters per second of a particle t seconds after it passes a fixed point. So we have our v meters per second is our vertical axis, and then our horizontal axis is our time. So this question's split across 2 pages, so you're going to have to just bear with me, guys. I apologise. I'll do my best to make sure you can see it all. So part A, calculate an estimate of the acceleration of the particle when t equals 3.5 seconds. So to do this, we need to draw a tangent at the curve at t equals 3.5 seconds. So we're going to go back to this graph. T equals 3.5, guys, is here, okay? So I'm going to go all the way up to my graph. T equals 3.5. So it's at this point here that I need to draw a tangent. So my tangent needs to follow roughly the curve of the line, guys. Okay, so roughly the curve. That I could have probably twisted it this way a little bit, but there we go. And once we've done that, we work out the gradient of that line, because to work out acceleration, we want the gradient of this line. So this coordinate here that I marked there is at 3.5 and 32.5. So I'm going to work with that, but then I'm also going to give myself another coordinate to work with. So here, so that's at 5.1 and 27.5. So I'm going to find the gradient. So I have 3.5 and 32.5, and then I have 5.1 and 27.5. So my gradient, guys, remember, move that out of the way in a second, is a change in y over the change in x. So my change in y, I'm going from 32.5 to 27.5. So I've gone down 5, and then I've gone from 3.5 to 5.1. So I've gone up 1.6. So I'm going to pop that in my calculator now. -5 over 1.6 is equal to -3.125. Okay, so that's my estimate of acceleration. Can't speak. My estimate of acceleration based on my gradient, guys. Okay, so wherever you draw your tangent, as long as you've looked to draw a tangent at t equals 3.5, work out your gradient and you're going to get the marks there. Part B, use 5 vertical strips of equal width to estimate the distance travelled by the particle in the first 5 seconds after it passes the fixed point. So again, we're going to need to use our graph, guys, okay? So we want 5 vertical strips. So fortunately, 1, 2, 3, 4, 5. So I'm going to start by drawing those vertical strips just up to the curve. Look, guys. One, 2, 3, 4, 5. But this is only an estimate, so now I'm going to make these into shape. So this is going to become a triangle. This, from this point to this point, is a trapezium. Here to here, also a trapezium. here to here, also a trapezium, and then from this point to here is a triangle. So we've got A, B, C, D and E. So we're going to work out the area of each of these strips and then add them together to get an estimate for the distance travelled. Okay, so we're going to start by finding the area of A. A is a triangle, so we're going to do the base multiplied by the height and then we're going to half it. So the base is 1. The height goes all the way up to here, look, so it goes all the way up to 15. So the area of A is the base times the height divided by 2. So 1 times 15 divided by 2, which is 7.5. So that's A. I should make that nice and clear really, shouldn't I? Let's do the same for the area of B. So B is a trapezium, guys. Okay, so we're going to do our parallel sides added together. So this side is 15, this side is 35. So 15 plus 35. Remember, we've got a calculator, so I might as well use it. I sometimes forget. So that's 50. But then we multiply it by the height between them. Well, the distance between them is 1. So 50 multiplied by 1 is 50. And then we half it because it's a trapezium. So we're going to divide that by 2. So that is 25. Let's do the area of C now. So C is also a trapezium. So we've got 35 and then we've got 31, 32. So we're going to do 35 plus 32 times it by the height, the distance between them. Well, for all of these it's 1. So times it by 1 and then half it. Okay, now find the area of D. D is also a trapezium. So this we said was 32 and this side, the other parallel side, is 25. So we're going to do 32 plus 25, which is 57, times it by the height, which is just 1, and then half it, which is 28.5. One more strip to go, guys. So we're working with E. So we're doing the area of E, and E is a triangle. So we have a base of 1 and we have a height of 25. So we're going to do base times height divided by 2. So 25 divided by 2 is 12.5. So we've got the area of all 5 of those strips. So to estimate the distance travelled, we need to add all of those areas together. So 7.5, 33.5, 25, 28.5 and 12.5. So 7.5 plus 25 plus 33.5 plus 12.5 plus 28.5. Let's be careful when we add these in. So 7.5 plus 25 plus 33.5 plus 12.5 plus 28.5. So that is a total of 107. So our estimate for the distance travelled is 107 metres, guys. So 107 metres to finish that question off.